The sound of steel shattering echoes across the frozen Polish plain. A German Tiger II, the most feared armored vehicle on the Eastern Front, sits motionless. Smoke pours from its turret ring. The 70-ton behemoth, designed to be invincible, has been reduced to a burning coffin with a single shot. 1,200 meters away, a Soviet IS-2 lowers its massive gun barrel and begins searching for its next target. The crew inside knows what the Germans are only beginning to understand. The age of the heavy tank has ended, not because of a new design, not because of superior numbers, but because of a 25-kilogram projectile that Soviet engineers created in desperate response to the nightmare machines rolling out of German factories. If you're fascinated by moments like this that change the course of history, subscribe to this channel and let us know in the comments where you're watching from today. The story begins in the summer of 1943, when German forces unveiled their newest weapons at the Battle of Kursk. The Panther tank arrived with its sloped armor capable of deflecting nearly anything the Soviets could throw at it. The Tiger, already terrifying, continued its reign of destruction. Soviet tank commanders reported engaging Panthers at ranges under 500 meters, watching their 76mm shells bounce harmlessly off the angled glacis plate. The standard Soviet arsenal had become obsolete overnight. In Moscow, the situation created panic among military planners. Reports flooded headquarters describing German tanks destroying entire Soviet armored formations without suffering meaningful losses. The 76mm gun that armed the T-34, the backbone of the Red Army's tank force, could not reliably penetrate the frontal armor of these new German machines at combat ranges. Something had to change, and it had to change immediately. The Head Armor and Tank Directorate received urgent orders from Stalin himself. Find a solution. The scientists and engineers at Soviet design bureaus began examining every available option. They considered larger guns, improved ammunition, new tank designs. The answer they eventually settled upon came from an unlikely source, a field artillery piece that had been in service for over a decade. The A-19, a 122mm core gun originally designed for indirect fire support, possessed the raw power necessary to defeat any German armor in existence. The challenge was fitting this enormous weapon into a tank. The A-19's breech was massive. Its ammunition came in two pieces, the projectile and the propellant charge loaded separately. The rate of fire would be painfully slow compared to smaller guns. But none of these concerns mattered as much as the fundamental requirement. Soviet tanks needed the ability to kill Panthers and Tigers at ranges where Soviet crews had a chance of surviving the engagement. Engineers at Factory No. 9 in Sverdlovsk worked around the clock. They modified the A-19 into a tank gun designated the D-25. The first prototype mounts appeared on the chassis of the KV heavy tank, creating the vehicle that would eventually become the IS-2. Named after Joseph Stalin, the IS series represented the Soviet Union's answer to German armor superiority. But the tank itself was only half the equation. The projectile it fired would prove equally important. The BR-471 armor-piercing shell weighed approximately 25 kilograms. It left the muzzle at nearly 800 meters per second, carrying enough kinetic energy to devastate anything in its path. The shell's design reflected Soviet engineering priorities, a massive steel body with a pointed nose cap and an internal bursting charge of high explosive. When it struck armor, even if it failed to penetrate cleanly, the impact transferred enormous force into the target. Soviet testing facilities at Kubinka began systematic trials against captured German vehicles. The results exceeded expectations. When firing at a Panther tank's turret from 1,400 meters, the 122mm shell didn't merely penetrate. It tore pieces of armor completely off the structure. One shot displaced the turret 500 millimeters backward on its ring. Another blast ripped a fragment measuring 580 millimeters by 230 millimeters entirely free from the turret face. The Tiger fared no better. During trials using the A-19 gun-firing BR-471 shells at 1,500 meters, testers documented devastating effects. One shell passed completely through a previously made opening in the front armor, traveled through the tank's interior, and exited through the rear plate. The entrance hole measured 140 millimeters in diameter. The exit hole expanded to 225 millimeters. 3 cracks formed at the penetration point, spreading up to 300 millimeters in length. A second shot struck the Tiger's turret and tore off a piece of armor measuring 580 millimeters by 230 millimeters. More significantly, the impact displaced the entire turret backward by 540 millimeters, ripping it partially from its mounting ring. A third shot ricocheted off the turret roof, but still formed a dent 25 millimeters deep and created cracks spanning the full thickness of the armor. The testing revealed something Soviet engineers had not anticipated. German armor, particularly on the heavier tanks produced late in the war, suffered from quality problems that amplified the 122 millimeter shell's effectiveness. The steel used in Tiger and Tiger II production had become increasingly brittle as German industry struggled with material shortages. When struck by the massive Soviet projectile, this armor didn't merely dent or deform, it cracked, shattered, and sent fragments flying through the crew compartment. The Tiger II, Germany's heaviest production tank, provided the most dramatic demonstration. At Kubinka, Soviet testers fired a 122 millimeter high-explosive fragmentation round at the upper front plate. The shell didn't penetrate, but the impact caused spalling across an area measuring 300 millimeters by 300 millimeters. The welding seam between the upper front plate and machine gun port burst along 3/4 of its circumference. Internal bolts holding the machine gun ball were torn free. The welding seam between the upper front plate and the right side burst, displacing the side plate by 5 millimeters. The tank caught fire internally. A single high-explosive round, without even penetrating the armor, effectively neutralized the crew and ignited the vehicle. The implications were staggering. Even near misses or glancing impacts from the 122 millimeter gun could prove fatal to Germany's most advanced tank. If you're finding this information as remarkable as the Soviet testers did in 1944, take a moment to like this video and share it with others who appreciate military history. Testing continued with armor-piercing ammunition against the Tiger II. At 500 meters, a 122 millimeter armor-piercing shell struck the upper front plate. The shell created a dent measuring 310 millimeters by 300 millimeters, 100 millimeters deep. On the rear side, a piece of armor measuring 160 millimeters by 170 millimeters and 50 millimeters thick cracked completely off. Multiple welding seams throughout the tank failed, including those connecting the upper and lower front plates and the driver's observation device, which was torn from its mount. At 600 meters, the armor-piercing shell achieved complete penetration. The entry hole measured 180 millimeters by 250 millimeters. A piece of armor on the interior side, measuring 580 millimeters by 500 millimeters and 80 millimeters thick, was ripped away by the impact. The shell remained lodged inside the fighting compartment. Turret shots proved even more destructive. At 2,500 meters with reduced propellant to simulate longer range, the 122 millimeter armor-piercing round still penetrated the turret front completely. A piece measuring 700 millimeters by 220 millimeters was torn from the turret face. The roof lost a section measuring 460 millimeters by 300 millimeters. Cracks ran through the entire thickness of the armor, extending over 1,000 millimeters along the welding seams. The Soviet conclusion was clear. The 122 millimeter gun armed with BR-471 shells could defeat the Tiger II at ranges exceeding 2,000 meters when targeting the upper glacis and over 2,500 meters against the turret. These distances gave IS-2 crews an enormous tactical advantage. They could engage and destroy Germany's most powerful tanks before those tanks could close to effective range. Comparative testing established the superiority of Soviet heavy gun armament in stark numerical terms. The 122mm D-25 gun could completely penetrate the Panther's 85mm angled glacis plate from 2,000 meters. The 100mm D-10 gun achieved the same result from 1,200 meters. The German 88mm gun from the Ferdinand self-propelled gun, firing the same ammunition used by the Tiger, managed partial penetration at 600 meters but could not achieve complete penetration. The German 75mm gun from the Panther itself could not penetrate the Panther's own glacis plate at any range. This last finding carried profound tactical implications. The Panther, designed with armor specifically intended to defeat the standard Soviet 76mm gun, was itself armed with a weapon incapable of penetrating its own frontal protection. The 122mm gun could engage and destroy Panthers from 700 meters further than the 100mm gun could, providing IS-2 crews with substantially greater standoff distance in combat. The BR-471's effectiveness stemmed from simple physics. A 25-kilogram projectile traveling at nearly 800 meters per second carries tremendous kinetic energy. When that mass strikes armor at oblique angles, the enormous momentum helps prevent the shell from deflecting or ricocheting away. Smaller, faster projectiles often skipped off angled surfaces. The heavy Soviet shell simply smashed through them. German crews began reporting a new and terrifying phenomenon in their after-action accounts. Tanks that had previously operated with confidence at medium ranges were now being destroyed by shells that seemed to ignore their armor entirely. Panthers struck frontally. At distances the crews considered safe, exploded, or caught fire immediately. Tiger IIs, supposedly impervious to any weapon on the battlefield, were being knocked out with single shots. The psychological impact on German armored forces proved as significant as the physical destruction. Tank crews who had grown accustomed to operating with near impunity now faced an enemy capable of neutralizing them at ranges where they could barely identify targets. Tactical doctrines developed around the assumption of German armor superiority became worthless overnight. Combat reports from 1944 onward documented the shift in battlefield dynamics. At the Sandomierz bridgehead in Poland, where some of the first Tiger IIs saw action, IS-2 units demonstrated the effectiveness of their armament in actual engagements. German heavy tank losses mounted as Soviet crews exploited their range advantage to engage from positions where return fire posed minimal threat. The IS-2's combat deployment followed a specific doctrinal pattern designed to maximize the 122mm gun's effectiveness. Heavy tank regiments operated in coordination with standard tank and mechanized units, providing breakthrough capability and serving as mobile anti-tank platforms. When German armor appeared, IS-2s would engage from the longest practical ranges, using their superior penetration to destroy threats before they could close to effective distance. The slow rate of fire, approximately 2 to 3 rounds per minute due to the two-piece ammunition, represented the IS-2's primary limitation. Tank commanders developed tactics to compensate. They positioned vehicles in hull-down locations whenever possible, presenting only the turret to enemy fire, while the loader struggled with the heavy projectile and separate propellant charge. Covering units provided suppressive fire, while IS-2s reloaded. Despite the loading time penalty, the devastating first-shot capability often proved decisive. When a single hit could neutralize any German vehicle, the ability to fire rapidly became less important than the ability to make each shot count. IS-2 gunners trained extensively to make their initial shots accurate, knowing that a miss meant valuable seconds of vulnerability while preparing the next round. The 122mm high-explosive shell added another dimension to the IS-2's effectiveness. Weighing 25 kilograms with a muzzle velocity of 800 meters per second and containing a 3.8 kilogram TNT charge, these rounds proved highly destructive against infantry positions, fortifications, and buildings. Soviet doctrine sometimes specified using high-explosive rounds even against armored targets, as the enormous blast effect could incapacitate crews through concussion and spalling, even without penetration. During the final push into Germany, IS-2 regiments served as urban assault vehicles, using their massive guns to demolish strongpoints and clear defensive positions. The psychological effect on German defenders watching buildings simply disintegrate under 122mm fire contributed to the collapse of resistance in many sectors. The development of improved ammunition continued throughout the war. The BR-471B shell, featuring a flat nose designed for improved performance against sloped armor, entered testing in late 1944 and began reaching front-line units in 1945. This projectile could penetrate the Panther's glacis from even greater distances than the standard BR-471, though it arrived too late to see extensive combat in Europe. American and British intelligence took note of the 122mm gun's performance. Post-war testing conducted by Western forces confirmed the Soviet results. The BR-471B shell penetrated 80 to 85mm plates angled at 55 degrees at ranges up to 1,800 meters. This represented fearsome capability against any tank then in service or contemplated for near-term production. The success of the 122mm approach influenced Soviet tank development for decades. Subsequent heavy tanks, including the IS-3, IS-4, and eventually the T-10, retained the 122mm gun as primary armament. The philosophy of overwhelming single-shot firepower established during the desperate struggles against German armor in 1943 and 44 became embedded in Soviet tank doctrine. Consider the moment when that philosophy first proved itself on the battlefield. Summer 1944. A column of German Panthers moves toward the front, their crews confident in their vehicle's protection. They've survived countless engagements against Soviet T-34s, watching 76mm shells spark harmlessly off their sloped glacis plates. They know the effective range of Soviet guns. They've calculated the distances at which they become vulnerable. Today, those calculations will fail them. At 1,800 meters, a flash erupts from a concealed position. The Panthers' gunners search for the source, knowing that at this range, Soviet weapons pose little threat. But the shell closing toward them weighs 25 kilograms. It carries momentum that Soviet 76mm rounds could never achieve. The first Panther lurches to a stop, smoke pouring from the turret ring where the shell punched completely through the armor and detonated inside. The remaining Panthers attempt to maneuver, but the IS-2 has already reloaded. Another shot, another hit. This time the shell strikes the glacis plate at an angle, but instead of deflecting, it smashes through with enough residual energy to penetrate the rear plate as well. The tank erupts in flame as ammunition cooks off. German tactical manuals had no response to this threat. The Panther's 75mm gun, while excellent against most targets, could not penetrate the IS-2's frontal armor at ranges where the Soviet vehicle could destroy Panthers with ease. Tiger crews found themselves in slightly better positions, as the 88mm L-56 gun could theoretically engage IS-2s at longer ranges, but the heavy Soviet tank's protection and the 122mm gun's superior penetration still tilted engagements in Soviet favor. The Tiger II represented Germany's attempt to regain armored superiority, but by the time it reached the battlefield in meaningful numbers, the IS-2 and its devastating gun had already altered the fundamental dynamics of armored warfare on the Eastern Front. The 70-ton German monster carried impressive specifications on paper, but its complicated transmission, high fuel consumption, and the deteriorating quality of German armor manufacturing undermined its effectiveness. Soviet crews referred to the BR-471 as their equalizer, where German technical superiority in optics, crew training, and vehicle quality had previously provided decisive advantages. The 122mm shell negated those factors through sheer destructive power. A single well-aimed shot could destroy any German vehicle regardless of its theoretical protection levels. The margin for error that German tank designers had built into their vehicles simply wasn't large enough to withstand 25 kilograms of hardened steel traveling at 800 meters per second. The statistical record reflects this transformation. German heavy tank losses mounted steadily through 1944 and into 45. While multiple factors contributed, including mechanical unreliability, fuel shortages, and air attacks, the inability to dominate armored engagements as they had in previous years proved decisive. Soviet heavy tank regiments equipped with IS-2s and their formidable guns provided the breakthrough capability that shattered German defensive positions across Poland and into Germany itself. The Battle of Berlin demonstrated the 122mm gun's versatility. IS-2 regiments rolled into the city alongside standard tank formations, using their powerful armament to demolish defensive positions block by block. When German armor attempted to counterattack, the heavy tanks could engage and destroy them at ranges that negated German tactical advantages. When infantry or artillery positions blocked the advance, high-explosive rounds eliminated them with devastating efficiency. One engagement at Seelow Heights in April 1945 illustrated the IS-2's combined capabilities. Soviet forces faced determined German resistance, including dug-in Panthers and Jagdpanthers. An IS-2 commander named Smirnov engaged a Jagdpanther at close range after his vehicle suffered damage. Despite the difficult tactical situation, the 122mm gun proved decisive. The shell struck the German vehicle's superstructure and penetrated completely, destroying it with a single shot. The massive caliber provided no margin for error to German crews. Final statistics from the Eastern Front campaigns reveal the extent of German armored losses. According to various estimates, over 30,000 German armored fighting vehicles were destroyed on the Eastern Front between 1941 and 45. While Soviet losses exceeded this number substantially, the Soviet industrial base could replace vehicles at rates German industry could never match. More importantly, by 1944, Soviet tanks could finally fight German armor on roughly equal terms, rather than requiring massive numerical superiority to achieve tactical success. The 122mm gun and its BR-471 projectile played a central role in this transformation. By providing Soviet heavy tanks with the ability to destroy any German vehicle at extended ranges, Soviet engineers broke the qualitative advantage that German armor had maintained since the beginning of Operation Barbarossa. The secret shell that made heavy tanks useless wasn't secret in any conventional sense. It was simply larger, heavier, and more powerful than anything German designers had anticipated facing. If you've stayed with us through this exploration of how Soviet engineering changed armored warfare, please subscribe to support more content like this. Your engagement helps us continue bringing these fascinating stories from military history to you. The legacy of the BR-471 extended far beyond World War II. During the early Cold War, Western military planners studying Soviet armored capabilities recognized the 122mm gun as a significant threat. American tank development programs specifically sought to create vehicles capable of surviving hits from this weapon while mounting guns powerful enough to defeat Soviet armor at equivalent ranges. The philosophy behind the BR-471, overwhelming force concentrated in a single devastating projectile, influenced ammunition development for decades. Modern armor-piercing, fin-stabilized, discarding sabot rounds represent the evolution of this concept, using dense penetrator materials to achieve the same goal of defeating enemy armor with single shots. The principle established by Soviet engineers in 1943 remains valid today. German reaction to the 122mm threat came too late to affect the war's outcome. Proposals for heavier armor, more powerful guns, and improved defensive tactics never reached implementation before the Reich collapsed. The Tiger II was supposed to restore German armored superiority, but its deployment coincided precisely with the period when Soviet forces had finally obtained weapons capable of defeating it at combat ranges. Some German accounts from the final year of the war describe the desperation that set in among tank crews facing IS-2s. Vehicles that had once dominated the battlefield now had to approach within range of enemy fire before their own weapons became effective. The psychological burden of knowing that enemy tanks could destroy you before you could effectively respond proved crushing for morale. The industrial equation underlying this shift deserves consideration. Germany invested enormous resources in developing and producing vehicles like the Panther and Tiger, complex machines requiring skilled labor, scarce materials, and extensive maintenance. The Soviet response came not from building more elaborate tanks, but from mounting existing artillery pieces in combat vehicles and providing them with effective ammunition. The 122mm gun existed before the Panther ever rolled off a production line. Soviet engineers simply recognized its potential and found ways to exploit it. This approach reflected broader Soviet military philosophy. Rather than pursuing technological sophistication for its own sake, Soviet planners focused on practical solutions to specific problems. German heavy tanks threatened Soviet armored operations. The solution was a weapon capable of destroying those tanks at ranges where Soviet crews could survive. The 122mm gun met that requirement. Everything else, including crew comfort, rate of fire, and ammunition capacity, became secondary considerations. The BR-471 shell itself embodied this practical approach. Its design incorporated no revolutionary technologies. Hardened steel, conventional explosives, and standard manufacturing processes produced a projectile that simply outperformed smaller, more sophisticated German ammunition against armored targets. Sometimes the best solution is also the most straightforward one. Testing records from Kubinka demonstrate this effectiveness in clinical detail. When the 122mm shell struck German armor, it didn't merely penetrate. It caused catastrophic structural failures. Welding seams burst, armor plates cracked, interior components were torn loose by the impact force even when the shell failed to completely penetrate. The phrase used in testing reports that crews would be incapacitated understates what actually happened inside German tanks struck by these projectiles. Consider the effect of that 580mm by 500mm piece of armor being torn from the interior of a Tiger II's glacis plate. This chunk of steel, weighing several hundred kilograms, didn't simply fall to the floor. It was projected inward by the shell's impact, creating a deadly secondary missile inside the fighting compartment. Even if the 122mm shell itself didn't enter the vehicle, this ball fragment would have neutralized any crew members in its path. The BR-471's performance against the Tiger II's turret proved equally devastating. At 2,500 meters with reduced propellant, simulating even greater range, the shell still penetrated completely. The turret lost massive sections of armor. Cracks ran through the entire structure. A vehicle that German propaganda claimed was impervious to any Allied weapon was being systematically destroyed by Soviet testing crews. This testing wasn't mere academic exercise. The captured Tiger II used at Kubinka had been abandoned by its crew at Oguldow during the fighting at the Sandomierz bridgehead. It represented actual combat equipment, not a specially prepared test sample. The results Soviet engineers documented reflected what would happen when their projectiles struck real German tanks in real combat conditions. The timing of the 122mm gun's deployment proved crucial. Had it arrived a year earlier, the catastrophic Soviet tank losses at Kursk might have been significantly reduced. Had it arrived a year later, the war might have dragged on with higher casualties on all sides. Instead, the IS-2 and its formidable weapon appeared precisely when Soviet forces were transitioning from desperate defense to sustained offensive operations. Operation Bagration in the summer of 1944 demonstrated the new reality. Soviet forces achieved breakthrough after breakthrough, with German armored counterattacks repeatedly failing to restore defensive positions. IS-2 regiments played key roles in exploiting these breakthroughs, their 122mm guns neutralizing German armor that attempted to seal the gaps. The advance through Poland and into Germany continued this pattern. German commanders attempted to establish defensive lines anchored by heavy tank units, but the IS-2's ability to engage these positions from extended ranges negated their value. Tiger and Panther crews found themselves unable to close to effective range before being destroyed by Soviet fire. Some historians argue that the BR-471's impact has been overstated, noting that German armor losses resulted from multiple causes, including fuel shortages, mechanical breakdowns, and air attacks. This assessment misses the fundamental point. The 122mm gun removed Germany's qualitative advantage in armored warfare. Even if German tanks had been mechanically reliable and adequately supplied with fuel, they could no longer dominate engagements against Soviet forces the way they had in earlier years. The secret shell had changed the equation permanently. The American experience provides an instructive comparison. U.S. forces in Northwest Europe faced the same German armor that Soviet forces encountered, but American tank crews lacked a weapon equivalent to the 122mm gun until very late in the war. The 76mm gun on improved Sherman variants could defeat Panthers and Tigers at certain angles and ranges, but nothing in the American arsenal matched the BR-471's devastating capability. American development of the M93 high-velocity armor-piercing round using tungsten carbide cores represented an attempt to achieve similar results through different means. This ammunition improved Sherman penetration capability substantially, but tungsten scarcity limited production to a small fraction of total ammunition output. Most American tank crews had to engage German armor without this enhanced capability. The Soviet approach avoided this limitation. The BR-471 used conventional steel rather than scarce strategic materials. Soviet factories could produce it in quantity without competing for tungsten or other rare elements. The industrial economy of the shell matched the industrial economy of the war that Soviet forces were fighting. This industrial perspective illuminates the broader significance of the 122mm gun's development. Germany invested in complexity, producing sophisticated tanks with elaborate manufacturing requirements. The Soviet Union invested in mass, producing capable tanks in enormous numbers. The BR-471 allowed those Soviet tanks to fight on equal terms with German vehicles that cost far more to build and required far more resources to maintain. The final months of the war saw German armor forces operating under increasingly impossible conditions. Fuel shortages immobilized vehicles. Spare parts became unavailable. Trained crews died faster than they could be replaced. But even had these problems been solved, the fundamental tactical situation had become untenable. Soviet heavy tanks could destroy German armor at ranges where German weapons proved ineffective. The secret shell had done its work. Berlin fell in May 1945 with IS-2 tanks rolling through the ruined streets. Their 122mm guns had helped carve the path from Kursk to the Reichstag. The BR-471 projectile, conceived in desperation after Soviet forces witnessed the devastating capabilities of German heavy armor, had evolved into the weapon that made that armor obsolete. The 25-kilogram steel shell, traveling at nearly 800 meters per second, changed armored warfare. It proved that no amount of armor could provide absolute protection against a sufficiently powerful weapon. It demonstrated that engineering solutions to tactical problems didn't require revolutionary technology, just careful application of existing capabilities. And it showed that the tank battles of World War II would be decided not just by the vehicles themselves, but by the ammunition those vehicles carried. When historians study the transformation of the Eastern Front from desperate Soviet defense to triumphant Soviet offense, they examine leadership, logistics, industrial capacity, and tactical doctrine. All of these factors mattered. But at the moment of contact, when a German heavy tank commander looked through his optics and saw an IS-2 positioning for a shot, none of those factors mattered as much as the BR-471 shell sliding into the breech of the 122mm gun. The secret that made heavy tanks useless wasn't really a secret at all. It was physics, applied with brutal efficiency by engineers who understood that the only answer to superior German armor was superior Soviet firepower. The BR-471 provided that answer, and in doing so, it helped write the final chapters of history's greatest armored conflict. Subscribe for more deep dives into the weapons and tactics that decided the outcome of World War II. The stories of the men and machines that shaped our world deserve to be remembered, and with your support, we can continue bringing them to light.